So what I've done here is made a copy of your state Quadricorn well, and I made a couple modifications. One of them is the liner. Instead of it being a 4.5-inch liner that's run throughout the entire open hole, I changed the liner basically to represent the drill collars in your drilling assembly. So it's a 130-foot long liner, if you will, and I manipulated the OD and the ID to represent average collar dimensions. So I did that by clicking on Advanced, and the box that pops up here, I just changed the pipe OD and the pipe ID, 2.813 ID. The weight doesn't really matter, but I changed it to be something close to collars. And I changed the depth of it, that we're going to set this liner basically just outside the previous casing shoe at 11,500 feet, and then the top of this quote-unquote liner is 130 foot shallower, which is the top of the collars. So that's the change to the wellbore builder. Within the cementing module of the liner itself, if I go into the string builder here, in the string builder, I made the running string equivalent to the drill string that you had in your trip-in scenario. So a little over 10,000 feet of 4-inch PTEC pipe, and then the heavyweight 4.5. We don't see it in this case, but I also added the 4.5-inch DS40 drill pipe on top. So that's how the quote-unquote liner is set up for this case. And then the other change for cementing purposes was in the fluid schedule. So the fluid schedule is set up like this, where you define your heavy pill, and this used to be called spacer. I just changed the name to heavy pill. 150 barrels is what it back calculated to be when I looked at the top and bottom of the pill in the tripping scenario. Put in the same density and rheology that you had, and then the quote-unquote cement is exactly the same density and rheology as your displacement fluid, your mud. And unfortunately, the schematic is a little bit misleading, because the gray area that looks like cement, in our case, is really just mud. It's the mud that will push that heavy pill out of the hole. And by telling it in the scenario that my target top of cement is at surface at 0 feet, it back calculates for me, okay, if you're going to displace this heavy pill all the way out of the hole, then I would need a cement volume of at least 230 barrels. So I just modify my cement volume. You notice over here it's checked cement to 229 barrels, which brings the trailing edge of the spacer out of the hole. And then what I've done in the driller's view plots is, you'll notice I've kind of manipulated how far along we are on the job. And you can do that by dragging this vertical line. A vertical line here would have no spacer in the hole, but really what you're wanting to simulate is at approximately this point in the well, where you've tripped the drill string in to, say, 11,500 feet. You've got the heavy pill completely elongated. This brown area is the heavy pill. So the top of the heavy pill would be displaced up to about 4,000 feet if you had a float in the string. And then at that point, we're going to start circulating. And if we flip over to the snapshot view, you'll see we've got ECD, friction pressure, and torque. And at the beginning of this, we'll have mud on the inside, heavy pill on the outside, and then, of course, our normal mud above the heavy pill. And what I can do now is just put my cursor on the gray stuff in the middle. It's drawn as cement, but remember that's just our regular 11.6 pound mud. And then you can see the ECD and ESD over here as I pull it down as the heavy pill gets shallower in the hole. The ECD at the bit really doesn't change, but if this wasn't cased, if you didn't have deep set 7-inch intermediate, the ECD felt up the hole would be getting extremely high as this heavy pill gets shallower and shallower and shallower. And then, of course, as soon as you start getting heavy pill out of the hole, the ECD starts dropping, and then until eventually, when you've got 11.6 all the way around, you're down back here to your less than 13 pound ECD. The other way of looking at is the driller's view plot. Now remember, the driller's view plot is just going to show me what the bit feels, and that's what this map basically represents. Is at the beginning of the job is when you trip into the hole, bottom of the hole for different flow rates is feeling somewhere around 15 pound per gallon. And then after you've pumped, let's see here, what is it, 275 versus 250. Once you've pumped 75 barrels, you're starting now to get heavy pill out of the hole, and the ECD gets lower and lower and lower from that point. And your pump pressure will drop also. When you get the heavy pill out of the hole, you'll see your pump pressure dropping off. So that is how you would set this up for Circulate now to heavy pill. And you can do something similar for sweeps or any other kind of scenario you might imagine.